Great. So I'm Leo. For those of you that don't know me, Quentin is my co-host. We're going to be showing a PCB sort of design tool. It's actually kind of a couple things put together, which we'll explain. Originally, it was an FRep rendering tool that we were trying to make faster, which Neil likes for a variety of things, but specifically for designing PCBs for the fab class. And Quentin did an iteration on that, which he can talk about a bit. And then we met in the spring in the how to make the rapid prototyping of rapid prototyping machines seminar, which we both sat in on. And we made a faster version of this FRep rendering tool for PCB boards. And then we've just continued to go down this rabbit hole of making it faster and trying to make it faster and then encountering other issues. And ultimately, specifically for the FRep purposes, we made one that renders with SVGs. So basically, what the tool is a split screen interactive live editor with this kind of dictionary format for describing shapes, and then an API for describing boards, which Quentin will go into in more detail. So that's an overview. Quentin, do you want to talk a bit about the kind of what got you started on this initially?
Yeah, so essentially last year I was doing the Fab Academy program, and I found the method that Neil used to produce his boards very nice, but it's too slow. So you have this single Python script that defines, I mean, it's kind of two jobs in the same script. So you have the definition of the language, yeah, exactly. So you have a bunch of primitives, and then you have the definition of components, and finally you have the PCB design, which makes use of all this meta language that was defined up there. So we wanted to not have all of this preamble and have a nice little editor. But my priority last year was just to make it faster. So it's kind of a nice system because in the end, the function is defined by a string only. And then you can evaluate that string. Yeah, this is an explanation I prepared about that last year. So yeah, the part I improved was the evaluation of the string, but not so much the string itself. I think that was already nice enough. So if you see the brown Pappert trace there, it's a single mathematical function. And the way you combine several shapes is doing logical OR between several logical functions. So it's all just one function. And when you want to evaluate it, what Neil did was use NumPy to compute this true or false value for every pixel. But what I did was use a shader instead. So we use the GPU to evaluate this Boolean function for each pixel, because GPUs are really good at parallelization in this context. They can, each of the shading units can compute this function on its own. It doesn't need any communication with the other shading cells. So it's a perfect job for GPU. And as you can see, I could not even see performance degradation. It was always constant time. There is, of course, a little bit of overhead because this shader needs to be prepared. So in my case, it was compiled every time the function changed. And so it only makes sense when you want to render plenty of pixels. But usually you do. For instance, at 1000 dpi, usually it would take a minute with Neil's system, but mine was interactive rates like 20 milliseconds or less.
What was the issue?
So yeah, this project.
What was the issue with this?
So why did we go further?
Go ahead.
Yeah. So, well, the only issue is you need to install Python. So we wanted something we could share with people and they can play with the design in the browser directly. But I knew nothing about JS. So I was so relieved when Leo showed up and said he would take care of the JS for me. And together we had a working version really quickly. But we wanted to keep this FRep aspect. So this is an example where it's pure FRep. We just demonstrate that you can evaluate a single Boolean function. And it's kind of a nice demo because, well, we should share this link actually. All of these links can be shared. I prepared a few. Let me, yeah. Okay, perfect. So you can play with the values. This is also a nice feature from Leo's editors and see the changes in real time. So this is a very simple abstract example. It has nothing to do with PCBs yet, but it makes use of the GPU. Okay. So if you want to show a simple example with the tiny, perhaps. I got it here. I made shorter links. It's easier to share. So click on this one. Does it work?
Yep.
Yes. So this is one of Neil's tiny examples. Now it's in the browser.
Do you want to take over and talk about this a bit?
Well, I was planning on making a board from scratch, but not in this system, in the SVG system. So you can introduce that one.
Okay. So basically, we got this working, and I'll open up a slightly larger example.
Yeah.
But the issue is that it wasn't quite fast enough. So specifically, I mean, you can see that this is still close to interactive speeds. But when you start to add two complex FRep strings, it gets to be a bit much. And the text specifically took a very long time because those descriptions are very complicated. So we were thinking about ways to speed this up, and it seemed like the best thing to do was to just use the native rendering systems in the browser, which meant kind of moving away from the FReps if we're just going to commit to making circuit boards in the browser and shifting to SVGs. So our most recent iteration of this is this SVG editor, which you can find here. And I'm going to talk a little bit about the basic drawing tools that you can use in here, which then we're using to construct PCBs. And then Quentin's going to get into actually making a board with it. Sound like a good order? And then, you know, hopefully you guys can spend some time following along and drawing some stuff in here. So basically, this just takes this is just a JavaScript editor. As we pointed out before, make this a little bigger. So what the whole shape is being defined, or everything that's being drawn is being defined by this object here, which has this shape property, and then a list of other objects in it, which have colors and this thing called interior. And because it's a JavaScript editor, we can use our native browser tools to get a better idea of what's going on here. And let's log the interior to see what this is. So what we're looking at here is a path data string for an SVG path, which is basically a Bezier with some different options for interpolation. But really what we're looking at for this one is basically just a polyline. So what it says is move to this point here, and then draw a line to this point here, and a line to this point here. And this ends up forming like the outline of a shape, which then gets filled with this color. Now, I could just dump this string in here. And it's the same thing. But it can be, so if you feel inclined to just write like plain path data strings like this, or if you're importing or exporting them from other programs, which typically in most vector editing software, you can reduce things down to paths and get this sort of string data, then all of that works perfectly well. But to make things a little more ergonomic, we also included this drawing library in the editor, which is one of just 3 things that are included. Quentin will talk about the other 2, which are specifically for importing components into the board and then actually defining the boards themselves. So this is just for defining geometry. It's a library I wrote for this other language I made called Gram. So this is like its own custom language, which then uses the JavaScript library underneath. And if you're curious, you can go to the Gram website to learn more about this. I made it specifically for laser cutting. So probably will hopefully be of interest to the people in the fab world who I had in mind when developing it. But you can also just use the plain JavaScript library itself. So this is kind of like an internal site I use just for testing out things in the library. But we've also exposed it in this editor. What's a little different is that typically I'm talking about the paths themselves for the SVG. And in this case, we're interested in like the interior, which is why it defaults to filling the shape. And the options for modifying like the stroke color or something aren't really relevant. But here's a simple example of just making a, oh, what happened here? Oh, I see. Of just making a rectangle. And then I can move it around too. That little dot there is 0, 0. So it doesn't actually come up when you download the shape. So those are our shapes. Here we also have limits, which defines what the dimensions of the page will be when you export this SVG. So I can change that here. All the numbers are scrollable, and then we can define our actual like units per the dimension down here, which we need when we turn it into a physical thing. So why don't I do just a little simple geometric shape here. I don't know if people are familiar with turtles, but it's a very nice drawing model, which has a wonderful history in ed tech as well, originating with Logo and a great thinker called Seymour Pappert. But I used it. I appreciate all of that stuff, but really brought it in here because it's quite nice for dimensioning things, because you can talk about shapes in terms of their lengths and angles. So when I just do one line, that's not coming up here. If we were to see what that was, what that geometry is, I can draw it again over here. And we'll see that we just have a single line. So when I try to fill that shape, which is what we're seeing in this SVG editor, there's nothing to fill. So, but if I add another line to it, we should start to see something here. So now we're getting a triangle, and it's open. If we were to download the path, then I can change this here. And let's try to make some interesting geometric thing. That's kind of nice. And we can do things like copy and paste this shape some number of times. And there's probably going to be more commands in here than you'll need for just making PCBs. I suppose if you want to make an interesting outline, they could be useful. But in terms of
what about CSG if you want to cut out?
Yeah, so there are let's make another shape here. It does support Boolean operations. So there's some clipping algorithms.
But are those your algorithms?
They are, some of them are, but it was hard to compete with Clipper, which is like a very battle-hardened clipping library that's been, transcribed to every language. So I ended up using Clipper for most of the main ones. Some of the thickening algorithms are mine, which I can show here. So because this was made for making like physical stuff, it might be hard to tell with just the fill. But doing something like this, it adds like an outline to it, which if we were to look at what this outline actually is, it's this. So if we fill that, then we get this SVG that we're looking at here. So some of those I wrote, but if I want to do a clipping example, let's make another shape here. We'll do a, well, let's close this. So now it's getting clipped, which, because it also has that fill rule, it can be a little hard to tell because we don't exactly know what the shape is. Maybe if I make it a rectangle, it would be easier. Here, I'll finish doing this. And then let's do, so there we go. That's a difference. Remember, this is just the origin, so that's not actually part of the geometry. But you can do Boolean operations like that. But when it comes to actually making circuit boards, where this could be useful is when you're defining wires, you could start to do things instead of having to, you'll see later that our wire API is a list of points, but you could also use those same like location, XY values, and define wires in terms of like angles or lengths or relative with like a vector from one point to another. But main point here is that there's a general purpose drawing library in here if you want to include that on your circuit boards. But I think I'll let Quentin actually get into making a board, which was the main topic for today. Does that sound good? Unless there's any questions about this drawing library. Cool.
Okay. So let me prepare this. Yeah, I'm having trouble with this laptop. Okay, so Leo, I can't share the screen right now. I'm not sure why.
Is it on your?
It's not an option, strangely. Can you do it?
Sure.
Okay, so the first, well, I guess we introduced basic shapes already. So the first I wanted to show is the component. So can you click the link right now? And this is just a single component on a blank canvas. So as you can see, it's defined, the actual footprint is defined at the top. Can you develop it?
Yes.
So it's a KiCat component. And this is actually the KiCat component for an SOIC 14 package, completely generic. It's the one from the FabCloud library. So I'm sending the link to that library because it's a bit obscure, actually. Quite often I find people don't really know where to find it. So I put the link in case you want to find it back. Can you open this?
Yeah, this is the cat. Yep.
Mm-hmm. And so in fab.pretty, you would have all those pre-made footprints that you can use. So it's a great resource. And I would say this is the main reason we wanted KiCad to be compatible with our system. So you can pick any of these. Perhaps, Leo, you can pick the, yeah. Well, this is quite similar to what we have already. Can you pick the FTDI one?
Sure. Go back. Which one did you have in mind? FTDI.
Yeah. This one. So yeah, this is the SMD one, so no problem. You can just copy paste that one in your editor, and it will become.
What's the vision for calling libraries beyond copying and pasting?
So what do you mean by that exactly?
Meaning, so in PCB.py, everything is in one file that accretes. In KiCad, there's a library manager. Here you're showing you go off to browse KiCad, open it, scroll, cut and paste, and put it in. You'd like to pull in a library.
So that's because the vision right now is that it's all a text. It's all a text file, and any components you might want to use is embedded in that text file. So there are pros and cons, of course, but at least in this method, the only thing you need to share really is the text.
So you don't want to have
it lets people use.
You don't want to have includes. You want to make it like I've been doing. You want to make it standalone.
Yes, for now.
Yeah, I think that so because it is just a general JavaScript file, you can just import things like you could do any other JavaScript. So yeah, that is something. It's actually, I guess you could do it with like a dynamic import now, if you don't mind making the rest of the file async.
Yeah, I mean, I would go in one of two directions. The PCB.py is you have a mother file that has just all of them, which actually isn't that large. It's like a few tens of K for all the accumulated fab library that you just paste that in by default. Or the other is you have an include. But having to scrape pages one at a time would be tedious each time you do a new board.
Mm-hmm. Yeah. What we added to make that a little more ergonomic, which you would remember from the class, is that instead of actually having to like copy and paste this in, if you just download it, you can just drop in components. So that automatically made this component here, which is using, this is one of, I mentioned there were 3 things that are actually included in this. There's the turtle drawing library for geometry. There's the PCB thing, which we're starting to talk about now. So the PCB class, and there's KiCad.object, which will take this string and turn that into something. Well, we can actually look at it. 1 and 1.
Yeah, so this format, we think it's quite elegant, and it's just a JSON. So if we could have a library of these, where every path is just an object in JSON, it would be quite elegant. The problem is, in a perfect world, we would have a really large library on this server, but we can't expect to know all the components the user might want to use. So it's still a debate for now, whether it should be hosted or completely on the user side.
Well, I mean, you don't have to pick a winner. Those can be blended.
That's true. So we could take the decision of at least making the entire
a standard fab library to start from, and then you can have include the
yeah, I agree with that. And it could be available in a drop-down menu to make it easier.
Yeah. Now, you're lightly skipping over the transition from FRep to SVG. I've been tempted to do this before. I like it. Were there any issues in going from FRep to SVG?
The main thing is, so to make this like more clear for people, we're talking about previously we're describing shapes with, we're still describing shapes with strings ultimately. So this is an FRep, which is that like closed form representation of these shapes. And we've shifted to the path data string. So that's the main change. I mean, it is different. I think the design decisions come into question with the fact that one is like kind of volumetric, or in 2D, it's defining an area, whereas the other one is a boundary representation, really. But it seemed to be pretty smooth, at least just for the PCB descriptions.
Yeah, because ultimately all those wires and rectangles, you can make them intersect physically or not. It doesn't matter too much, right? You just want to draw them. So even though in this case, Leo does it the proper way. So those wires are really a single SVG shape. Mm-hmm. But we might as well just put a bunch of rectangles in the same layer. It's all the same.
Yeah.
As long as it's being drawn.
So one thing, like the SVG, it also is, a visual format too, where you can have properties of the SVG that don't necessarily correspond to the geometry, which I was talking about a bit when I was showing Graham, which was showing like the actual line itself. And in here, we're only looking at like the filled in portion. So this shape, this rectangle here is defined by the points around its border. But it's one of the decisions we have to make, which could go either way, is like, well, when you actually want to draw it, like, should you talk about if you're only interested in the picture, which with the FReps, you'd get out the bitmap afterwards. And then, in mods, you would do like an outlining algorithm to get the actual geometry. And if that's all you're interested in, you could also generate that through the SVG. But if you're working with the SVG with discrete data for the geometry, then you can also choose to work with the geometry directly.
Right. Two related thoughts. So one is, in some cases, avoiding the need for the CSG library, I've done just visual CSGs. It's like ZBuffer. To some degree, you can like subtract a shape from a shape just by the drawing order.
Yes. But then when you actually want to, I think there are situations later where you actually do want the geometry. So we did, the extra work of like making it so you get real geometry out
right
from the SVG.
Because the reason I mentioned that is thinking about the layer of programming, there's a straightforward, nice, mature, simple interface for JavaScript to construct SVGs. So, in theory, you could do all of this a layer down by writing JavaScript that constructs SVG just using that spec.
Mm-hmm. I think we'll show, Quentin, can you send the more complicated board?
Yep. If you want, I can also try to share screen.
Yeah, I just wanted to show with this point, with the actual getting the geometry, how that comes up when you import it.
Yeah, so let me share the link. That's the more next example.
So here's the same board as we were looking at initially. And if I'll just download this, if you open up, here it is to scale. But just to Neil's question, it's out of scale here, but that's because of, I think that has to do with this program and not actually with the description. So they also flipped it, which is unfortunate. But what I was,
so where are you right now? Is this SVG in a browser?
This is just an SVG editor in a browser.
I don't know that. foxysvg.com.
It's a really nice editor.
Huh.
Yeah, ignore
the other day
when I scaled it up. But what I wanted to demonstrate is that, so if you were to just like draw it because you were only concerned with the color, and we're okay like getting the bitmap after, kind of like hacking the Booleans, like it's faster for rendering, definitely. It's really easy for the browser to do that. But then what you don't get afterwards is like, we can go to these paths and we actually have like the geometry for the path. Yeah.
Right.
Which is nice. And then one of the other things that, you know, benefits you get from actually doing the work of like dealing with the geometry itself is you almost have these kind of, so in a typical like board design program, you'll have tools for design rule checks. And you kind of fake those in here by, let me see if I can get one of these. Yeah, you'll see like when I move this up, when I start getting my wires intersecting, which would definitely be a problem, it kind of alerts me like, hey, this area is now bounded and probably your traces are hitting in a way that you don't want them to, which none of that was intended with the program to like give a warning, but it just naturally occurs from doing the work of like getting the actual shapes out. So then when it fills it in, it says, hey, this is a big shape, and it becomes immediately evident visually. But Quentin, did you say that you could share now?
Well, yeah, my PC is feeling a little bit better, it seems. I can try, at least.
Okay.
I have a question first, though. How easy would it be to add an SVG to the to the design with your API? I think it would be pretty easy. So you could actually have PCB components that would be drawn as an SVG by the user. So you can make artistic PCBs as well, right?
Yeah.
It's really straightforward with your API, I suspect. Okay,
yeah.
It still doesn't work. I'm really sorry. You have to do it yourself.
Now, in the opposite direction, I had always expected somewhere in the FRep's future was CAD models, so 3D FReps for part shapes.
Right, but for that, if you want to do it in real time in the browser, it's gonna be a tough challenge.
I mean, yeah, that would need Matt Keeter's thesis, overloading interval arithmetic to recurse over octrees and parse expression strings and all of that.
Indeed.
One other thing, I mentioned to Leo, I've been making so Arumbo is working great, and I've been making so many of these motor controllers that I need a bigger run, so it's going to send off a PCB. Ages ago, I wrote FRep to Gerber, and I did it by like brute force by just sort of having raster lines that I turned into flashes. And so I'm going to go back and dust that code off again.
Yeah, I feel like that would be. So the Gerber file, as I recall, it's sort of like a vector file too. Like you.
Oh, it's horrible. No,
yes.
No. It's much worse than that. It's horrible. It dates back to old photo plotters. It's flashes.
But isn't it a bunch of shapes anyway?
No, but right. But conceptually, you have a wheel with shapes that you flash. It's a horrible format. It has no excuse to exist.
Well, that's the thing. For a few days, I've been very frustrated with Gerbers, but for the wrong reason. basically I was trying to use.
Sorry.
So I was really frustrated with Gerber finds, but the reason was, okay, do you see the CNC on your desk there?
Yeah.
Yeah, it's not made for PCB milling, so the most convenient way is to use mods, which takes images, not Gerber. So it was annoying. I had to use FlatCam to convert the Gerber to G codes for this specific machine.
Yeah, I mean, there are lots of open Gerber viewers that can convert Gerbers to images.
Yeah, but it feels wrong because I like Gerber files personally because I often order PCBs from a fab house, and it's the industrial format. So
I mean,
that part.
Right, you like them for how they're used. It's decades ago. The industry should have moved away from it. It's just a horrendous format. But having said that, for exactly the reason you said, I'm going to go back and dust off the FRep to Gerber export.
Interesting. But how would that work though? Because
I have to remember how I did it, but I think the way I did it is it's sort of comical. I rasterize it, and so the flashes are scan lines, and I have a series of scan line rectangles, and it's
then you introduce back pixels, which you.
Oh no, but they're already there. I mean, there's effectively a pixelization from the decomposition of the board to the flashes. I mean, there's a nice computational geometry problem to decompose the filled interior into, overlapping shapes. And I don't forget if I rasterized it or if I did something smarter, but I think I think I did it because if you look at the just the resolution that the boards are fabbed, sort of the mod spirit, rasterizing at the resolution of the board house is not heroic for the file size.
Well, in that case, we can do it from FRep or SVGs or images. It doesn't matter.
I feel like if Gerber files that are just like sets of points though, with the associated layers. So if you have the polyline, can't you just?
Let's see. I had a period where let's see, RS is at 1 or 274 is the spec from it, and at one point I spent a while with it. I don't think there's anything like a polyline in it.
Okay.
I'll have to go back and remind myself.
Should we try to do our minimal example? We got.
Yeah. So you had. So did you succeed in drag and drop the?
Yes, but I think even before that we could start with. So we showed how you can import components, and then I logged that, which I think is where the interesting questions came up. But let's also talk about how you can just define this as something that could be a.
Yeah, because in the end, this is what it becomes, right? So we wrote a nifty converter that lets you use KiCad, but it's a side effect. You might as well design it in this format. So it's a JS object, and as you can see, a pad is just an object itself, which has a position, shape, and the layers that it will affect. And this is the nice thing. Those layers get created on the go when you add components. So because in KiCad, the front layer for the copper was called f.cu. We kept that name because it naturally becomes that when you add the component. So here Leo created one that has the back copper shape, but you can make it F and it will be on the front, just like that. And of course, a pad can also be on several layers as well.
And we can also, yeah. So if I put it here, we're rendering both, so we'll get a combination of those two colors because now it's being rendered on both layers. or it actually is on both layers.
So unlike all the previous iterations of this project, now you can actually have solder masks and etc. stencils, whatever you want.
I noticed there's also a couple other things coming up in this drawing. So there's a pad label. So there's two layers that get automatically created for the board, which are the pad labels and the component labels. The pad labels get pulled straight from the keys in this object. So good name for will just get generated automatically. And one of the reasons we do that too is that, I don't know if this one has any good names for it, but oftentimes these files will also have names for the pad that will pull in automatically. And you'll see that on the more involved examples. And then the name for the component is, well, once you have a component, how do you actually add it to a board? I'll let Quentin describe that.
Yeah, so first you create a PCB object, and then it has a nice API that lets you add components or wires. So the next line of code you see here is board.add, and then it takes the footprint object that he just created, and then a bunch of optional arguments. You can skip all of these actually. But if you want to translate it or rotate it, you can try to, Leo, if you try to rotate it in real time, I think it's quite funny to see this because the text remains horizontal.
Yeah. So
and
then
again,
I rotate
yeah.
I keep forgetting my comma.
Okay.
And so that's for adding components. They also take a name which is displayed on the component label layer, but it's optional. And after that, you might want to add a second of these. Leo, you can just do that at a different position. And of course, you can use the same footprint as many times as you want. And then you might want to add a wire to these. So can you shift it on the right a little bit as well? Where any of these? That's the Y. Yeah, okay. that's fine.
A couple notes. Do you have any way to go from the right to the left to do graphical interaction like Matt Keeter did that ends up in the text?
Not yet.
Well, now that we use SVG, we have the opportunity to do this.
Okay.
Because it's trivial to detect the mouse, isn't it?
Yes.
I mean, between SVG and JavaScript, yeah. I mean, right, you can have behaviors associated with the SVG objects.
Yeah.
And then how do you save, download, upload?
Yep.
Oh, it's on the bottom right. So if you don't know what you get, the SVG and
no, the program.
So, right now, you just copy it. Just copy it.
You just copy it. I had a few comments about that today. I practiced this workshop, and they said, you should really have a button for that, you know?
You need, I mean, just like in mods, there's when you're editing a module, you know, you can upload, download, save. You need a little controls for that.
Yeah.
Mm-hmm. Okay, so you added two components. Now it's a good time to add a wire. Yeah, you can have fun with the colors, but okay, board.wire. And then it just takes a list of XY coordinates. But
to understand the API, do you ask Leo and Quentin?
At the moment. Or you could watch our very informative video from Fab 16.
But by the way, I checked while you were working. Gerber, it's a pathological combination of what we were saying. You can describe a polygon, but the polygon is to describe an aperture that you then flash.
Really?
Yes.
That's insane. Yeah, I see it right here. Aperture list and then a bunch of coordinates.
Right, and so you can describe a polygon aperture, and then you have to flash the aperture. It's horrendous.
Okay, so now Leo added the wire, and as you can see, it's just a list of lists. Each of these is a XY coordinate, and then there's the width as an additional argument. Is there a default width, Leo? I don't remember.
I don't believe there is a default width. No, there's not. So it needs the width.
Oh. All right.
There's one more.
And then optionally, optionally you can add it on a specific layer, but by default it's the front copper. But as you showed here, it can be on the back as well. And of course now this wire has no reference point, so it's not a very useful wire, and that's when you want to reference existing pads. So the simplest thing you can do is just taking the coordinate for the first pad and the second pad, and this will make a diagonal wire. So if you do that, Leo, the first coordinate will be, let's say, d11c.pad. And then this takes a key. The key is the name of the pad. So in this case, it's named 1, but it's the string 1. So like this. And now it starts.
I think it might actually work with just this too, but you shouldn't do that.
Yeah, it doesn't feel right, because in general it would be a string, wouldn't it? Because it's the name of the pads usually. And there you go. That's a diagonal wire. But in proper PCB design, this is not really useful. So if you want to give it a knee, then you would add 2 extra points, or at least 1. Let's do it with 1. And this extra point will have the same y coordinate, but a different x coordinate. So you can, the x.
I like the huge task you just sketched for yourselves, which is, since those are SVGs, each type of SVG could have behaviors. And so the wire type of SVG could have a behavior, which is when you click on it, it adds a node.
Yeah.
You could define behaviors associated with each type of object. So each becomes a method, not just a shape.
But Leo, if I'm right, this wire gets mixed with the pads in the end. In the current implementation, it's all one path, isn't it?
It is currently, but that can be adjusted. Yeah.
Okay, so if you can change the x coordinate a little bit, so add a constant to it.
To this one?
On the wire as well, yeah. Plus, I don't know, 0, 0, 1, or yes. And so in this case, you see that you might want to add a second knee, which Leo can do. He can add an extra point, which is very similar, but it's the other way around. It will have the same x coordinates as the other point, but a different y coordinate. Yeah, something like that. But can you change the y coordinates? So the first one would be d11c and d11c2.
For
this one.
This one?
Yeah.
But you wanted a different y here?
No, same way. Because it's a horizontal. You'd see it will be fine.
So here's what I'm wondering, as we're talking, right now you have 3 windows open. Your code, the graphics, and then the object tree. you know, SVGs naturally can tell you themselves their construction tree. And if you associate methods with them, it's sort of self-documenting. The SVG carries its own code. Let's see, you have the code above the SVG. The code could also be sort of below the SVG, just built into it. So the SVG object tree is the document construction.
Mm-hmm. Yeah, there would be some more significant changes there with the way that the layer system works.
I don't know it makes sense. I'm just speculating as we're talking, but right now you have SVG in a browser making SVG. You have JavaScript in a browser that's manipulating SVGs. It's very close to the SVG. You know, the native format could be an SVG that contains JavaScript.
Mm.
Well, what if it's if you put it in a comment in the SVG? This is something you did in the past, Leo, for Gram.
Yeah, I do that. I can show that. So here in Gram, if you download this SVG and then clear this, when I re-upload it, it's like stored in the SVG, which we could do something similar here.
Yeah, can you show that the SVG itself?
SVG, yeah. Here, let me open it up over here.
But yeah, again, this whole train of thought is triggered by, I like the idea of the SVG objects having methods associated with them for how you manipulate them.
Mm-hmm. Yeah, but I guess it would mean wires are a completely different kind of objects, which is not the case currently, but that part would be quite easy to do. Mm-hmm.
So here,
let's see, we don't see the window you're sharing.
Oh, you can't see.
You're only sharing your browser.
I'll paste it into the text editor. So this is what the SVG looks like. And you'll see it's here is the actual code.
Okay.
This very, very long string on that property.
Yeah, got it.
Okay, Leo, so can you add the footprints we downloaded previously?
The which one?
The KiCad module you downloaded. Can you add it?
Oh yeah, add this component. Yeah, definitely. So if you want to add this component, then let's do SOI C15 or So if let's add it, there it is at the origin. And you'll notice that the precision of this is based on how many decimal points you have. So we'll keep that when you drag it. So if you want a finer resolution for your drag, you just add another point.
So are either of you using this yet to design boards?
We've done a few boards. Quentin has done some that he's made as well.
Yeah, I can share a few links. Right now we have 2. But the truth is, I was working on a Python script that would convert your FRep boards to this new format.
Good.
It's in the making, because the dream is that every single one of the Hello World boards would have an equivalent in this browser.
Yeah, as it settles, I'll be happy to deprecate the PY and just migrate them all to this.
Yeah, because people can view and play with the board at the same time.
Yeah, I mean, I want to do that. There's a slightly perverse thing, which is because it's such a non-standard format, it forces people to redraw from scratch. But on the other hand, letting them reuse is fine. So yeah, keep me posted. I'm happy to migrate to this. I mean, we could make a goal for the next spring cycle to try to make that change.
Yeah, agreed.
Okay, 229. I'm gonna have to drop at 2:30.
All right.
And then just Quentin, in the Arumbo repo, I've got servos and steppers happily working, and I'm ready to start making more complex machines that way.
Oh, okay, wait, 10 seconds. So I was in Agrilab and I took a bit of time to design an alternative to your stepper board.
Okay.
It has a hole in the middle, look.
Oh, nice. Oh, here,
So,
this is the way I'm avoiding the hole in the middle is just mounting it going up instead of down.
yeah, I saw that, but it's, you know,
it's a hack.
It's not proper. So
it's not
yeah.
proper. Sure. Nice. Send me the link for that. I'll share it.
Yeah, well, it's brand new. It's from yesterday.
Okay. And if I could just take a minute before I drop, I can show you. I'll do a quick show and tell.
Sure.
Yeah, go ahead.
So let's see. I want to go to. So in the Arumbo repo, this is board and code for steppers. Then this is servos, and the servos are ridiculous. What I'm doing is there's one USB packet per PWM pulse. And then if you put it all together, here is, right now I just didn't do the CAD to mount the pen holder, but right now I'm drawing with the steppers, and then this is the Z servo doing the pen up and pen down. And yeah, and then the motion is happy. I mean, this is doing bigger drawing. And the way I ended up settling on to do it, that's working really well, is we're still working. There's some funny differences between Linux and Windows, but the heart of it is I'm running two processes. One runs the UI, and then one does the real-time stuff. And the real-time stuff is an event loop. So I spin an event loop. I get nanosecond clock timing. The event loop on a desktop PC runs at about 10 kilohertz. And so every 100 microseconds, I ask, do I need a pulse event or a motor step event? And then the UI is putting events in the event loop.
Okay, really interesting. But do you think it's so important to do it in real time? Because I was thinking of a much lower bandwidth protocol where you send a position, not.
Yeah, no, but so what you're describing is what Nadia and Jake have done in their theses, which is you have a network and you send packets and messages and all of that. And Jake's done a beautiful job of that. The reason for this is sending a packet means there's state in the node on both sides for what is the packet and when do you execute it and how do you synchronize and all of that. What's so interesting about this is the embedded code is comical. All it knows a single thing, how to make a step for a stepper, and it knows how to make a pulse for a servo, and that's all it knows how to do. And it's completely stateless. And all of the state really lives. Sort of all of the intelligence is in the event loop.
On the PC, yeah.
Yeah, and so this is really happy. The drawing machine is a good hello world. I'm ready to start making bigger machines that way. And then just the Windows issue is multiprocessing is different between Windows and Linux. And then the Windows timers are kind of weird. And so right now I'm working with Sean Liu at SolidWorks on trying to align those. But yeah, with those notes, it's very happy for really, really simple machine building.
One of the qualities that Jake emphasized is being able to have kind of arbitrarily nested networks.
So what Jake is doing scales way beyond this. So right now I'm limited by this, roughly 10 kilohertz event loop to roughly few kilohertz stepping. He has topology, he has bandwidth, he has hierarchy. In all sorts of ways, what he's doing is much more scalable than this. This is very much aimed at, it's very much a hello world. It's minimal machine building. It's, if you want to make a hello world with a couple degrees of freedom, Jake's stuff has a D51 with complex code in it. This is just, a D11 that knows how to do a single thing in life.
Yeah. Well, I guess right now, the controller, it's flat. There's only one level, which is maybe sufficient for a few, but.
But the but to that is, so, I'm doing power, address, and this event loop over USB. I'm using standard USB 3 powered hubs that have 7 ports.
This we like a lot.
7 ports is enough for 3 steppers. That this could have encoders, some servos. The kinds of machines behind me are within the ballpark of that complexity.
Mm-hmm. But so, about the servo, sorry.
Yeah.
About the servo, in my view, it would still be stateless if all you did was sending the pulse length.
Oh no, but that's what I'm doing. Meaning, for the stepper, I send step and direction. For the servo, I tried actually sending pin high or pin low, but the timing granularity isn't good enough. So for the servo, the message for the little, this is my little servo board, and the message it gets is 2 bytes that give me a pulse duration.
Yeah. Okay.
Yeah. But it's still sort of in the Arumbo spirit that it's sort of the minimum distinguishable task. But the event loop was a little bit too coarse to actually do the pulse duration that way.
Mm-hmm.
Yeah, I think the project Quentin and I were hoping to shift to in the fall when we get this running better was actually making those sorts of boards, or perhaps exactly the more peripheral.
Yeah, because the reason I want to do the Gerber is this is a really good, and I like the design, Quentin, for the Hello World machine building. I've also become a real fan. This is this zero stretch, high density, something or other twisted fishing line. That I've fallen in love with. And so what I'm looking at is, in between Jake's belts and Jens's rack and pinions is using this as a way to route forces. And so I have a bunch of updates to the fab inventory of bearings in this fishing line, and I'm ready to start making axes out of it. Using the zero stretch fishing line as the way to route for the axes.
Interesting. And flexors, perhaps.
Well, yeah, perhaps, but let's see. I do have to drop in a minute, but let me just show this to you quickly. So yeah, here so the 80-pound test version of this is ultra high molecular weight, something or other, sort of zero stretch, zero twist. And it's been really surprising. It's just sort of like a universal. So one of these is 80 pounds and you could double them up if you want a little bit more. It's sort of like a universal way to transfer force. And then I've been going through commodity bearings for size and benders and performance. And I'm going to add a whole bunch of bearings to the fab inventory. And I'm coming around to the fishing line in the bearings is kind of a universal force distribution that's commoditized, cheap, scalable, easy.
Yeah, we should have a Roomba iteration with only that.
Yep.
To be a nice challenge.
Yeah, and so I'm almost done on the drawing machine. I just have to do the CAD for the pen, and then I'm going to start doing axes this way.
Yeah, okay.
Okay, so I like where you're going. Good goal to try to get the spring moved from PCB to PY to this lineage. Okay, thank you. Bye-bye.
Bye.
Bye-bye, Pete.
Yeah, so I think now
left the workshop. Sorry, go ahead, Quentin.
Well, we can take questions.
Yes.
So if you want to do a hands-on Q&A
or if
about this,
somebody else would like to try using it with the creators here to answer your questions. The only documentation at the moment.
So I sent you a bunch of links already. You can click any and try to play with it. I'd be happy to have feedback right now.
Are we going to integrate it into mods? Yeah, I mean, because they're all like in the browser, we definitely could. One easy thing to do would be like as an export option, if it just sends it straight. Like if we could add a button where you click it and it opens up in mods and it's like ready to mill whatever it was you had. I think that would be a nice thing to do. You could also just like embed the editor in an iframe, like in a mods thing. Not entirely sure what the benefit of doing that would be, but but all levels of integration are possible. And I think that the mods is still popular for actually milling boards. So it would make sense to add that as like an export option. Yeah. Yeah,
but we might as well have a node that takes the code and produces the SVG. It would be a special mods node.
Mm-hmm.
Could be fun. So that's one way to go with it. Can you share the screen again?
Sure.
I'm really sorry, but my PC is broken. It has a seizure.
So these are our two complete boards. One question we had, could have been interesting to ask Neil, but I guess we could just kind of survey the community, or perhaps here. Trying to pull up the chat. Or perhaps Pete is the only person who's like actively here at the moment. Let's get Pete's opinion.
Thanks, Pete.
Yeah. Yeah, we're not entirely sure where we want to host it. So currently I'm serving it like from subdirectory on my personal site. But there's always this kind of question with these fab projects of whether we use GitLab or GitHub. Like the more, obviously the CBA uses GitLab, and some of the fab community projects are on there, but more people have GitHub accounts. So we haven't yet decided where it will be hosted. I don't know if anyone has an opinion on that. But for the time being, I'll keep it live here if you want to use it. I can also just maintain this link kind of indefinitely. I don't think I needed the SVG PCB path. It seems more like a fab stuff.
GitLab. Yeah, well, well, we like to use GitHub for more visibility usually.
Yeah, so one thing is like if other people, non-fab people want to use it, definitely then the GitHub is there. Yeah, but also for feedback on the API, did you want to do a specific thing? Exactly more other?
No, but I have a specific question. So I mentioned importing SVG to this editor. Do you have an idea what it would look like?
Yeah, there are different ways you could do that. Yeah, so one way is like, so as I was saying, this, I have an example. I got rid of it, but the paths, like I'm using these turtles as shorthand or as a more ergonomic way of getting this path data. But the actual geometry now is like the path, SVG path data is the format. I'll send a link to that too. SVG path. So this is what we're using, and specifically it's this data attribute is what we use to describe geometry. And the reason I did that is because stuff like this is a nice example. So this is part of the more general set of just any SVG shape. You can certainly make a circle using this path data, but on a regular SVG, you can also describe it as a circle. I think that we prioritized getting good geometry out. So like geometry was the advantage of turtle versus native SVG. Yeah, well, I can talk about that in a second. I'll reiterate the question then, but it's a good question. So the issue with just importing an SVG straight up is that
it's not all paths.
Yeah, it's not all paths, but what we can do is turn it into a path. And SVGs are like sort of like, that's not an uncommon operation to do.
Yes, in your backend, you're using an SVG engine. Does it have such an option?
Yes, there's one.
Okay, then you could just turn it.
The drawing library. Yeah, so that would be the easy answer. Is we can just pull it in like a string, and then convert it to the same sort of path data that we're using for everything else.
But at the moment, if you copy paste the path example, the line above, this is a perfectly valid string in our API.
Which one?
Yeah, any of these.
Sure.
Any, really, yeah.
Yeah, so if I just take this and I go in, clear this out.
Yeah.
Be able to pop it here.
This is the minimal example. That's, yeah, those values.
Yeah, and this is going to be like, well, I'll make the viewing window bigger. And then center it. And yeah, so see this here? And it may have gotten, yeah, it gets flipped because we flip it because the SVG like Y direction.
Oh yeah, the Y is bottom, yeah.
But that is, I guess, this shape here. These handles are not part of the shape. It's just showing the handle information. And then that's here. So that does work. Pete had a question about,
yeah, turtle.
Yeah. So why use turtle versus SVG? Well, that's a good question. Something I've obviously thought about a lot. As I mentioned, like I developed turtle for this drawing language, which is supposed to be an accessible language for parametric design of objects. And I think, like, yes, there's anything, any of these shapes. Well, actually, it's about how you want to think about describing something. So one turtle specifically, there's other parts of Gram, but for the turtle specifically, what that is really offering you is this ability to like think about a shape in terms of its intrinsically. So in terms of like the lengths that this tool has to travel or the angles that it has to turn, which then correspond to features you're interested in your shape ultimately. So if I were to describe this shape as, well, why don't I make a I don't know, I'll just make a certain. I'm making some component like this, some kind of weird bracket. And I'll add a little bit of thickness to this. So, well, maybe right away, like if I were to try to describe this shape with an SVG, that would be pretty tricky. I'd have to like know all of these points and then specify them. And so the first one is maybe doable where it's like, is it procedural versus declarative? Well, in a sense, it's both, but I think maybe both of the formats would be considered declarative. But yeah, you're right. Turtle does support procedural programming more, where SVG doesn't. Where SVG is not really like, it's not a programming language. There's maybe somebody that's going to disagree with me on the internet. But it doesn't support that sort of like procedural operation. So certainly in terms of like maybe an even more clear example is if I do something like this, where it's like, you know, a typical for loop. So this is going to make our squirrel. Then that would be super hard to describe as an SVG, and it's, you know, described quite well with Turtle. And then we can do interesting things to this. And then if we want to make this fabricable, we can also do that by, you know, adding some thickness to it. And things like that would be, you know, extraordinarily difficult with just an SVG. So yeah, easy answer is like, one is you can kind of write like programs that define shapes, where like it's the process that makes the geometry. And I think that being able to think about the geometry as a process will allow you to parameterize it in the ways that are meaningful to you, such as a dimension that you're interested in. Or in the case of these boxes, you know, what is the SVG tag for tabs? Like you need a program to actually generate that. But here I can define this shape in terms of, you know, its width, its height, its tabs, because the geometry is defined as a program. Are there Boolean operations in Turtle? Yes, there are. So if I make a circle, and once again, this is a custom language. So all of these things you can also do, but they'd be in JavaScript. You could also just use the JavaScript library. So let's see, if I do this, and I'm going to add these to their own layers. And I'll translate this over a little bit. And then if I do a union or a difference, then I have these Boolean operations.
Yeah, so it means that we didn't really need the FRep to make those Booleans. So it's a perfectly valid framework to compute the PCB shapes anyway.
And it's a lot more yeah. Now I'm just playing around with this. Hopefully it will make you want to play around with it as well. Yeah, so there's lots of different ways. There are definitely advantages to the FReps. And it's a very elegant way of describing geometry. So we're still working on some other projects to try to speed up the FReps, doing clever, horrible things on the GPU. And on certain hardware, there are versions that are like fast enough now, but I think it really depends on, you know, the representation for the format for the geometry depends on the problem that you're interested in answering. And it's not like there's one type of geometric description, which is just better. So the FReps tend to be good for doing like kind of arbitrary math transformations to stuff. Like if you have a shape that you can describe well with a closed form expression and you want to twist it, Like that's an interesting operation, which, or the Boolean ones too are a good example where like the clipping algorithms in Turtle are like 40% of the entire code base. It's like tens of thousands of lines of code. Whereas the clipping, these Boolean operations in for the FReps are a single logical operator. So some things are easier expressed in with different formats. It's a good question though. Any other questions? Go back to the
Yeah, so if we were to implement the interactive part on the right side, how do you see it? Like clicking on
there's a
wire?
couple ways that could be done. One is if you just render, if you don't use this format, or if you like were to render the board itself, so you add that to this, there's a lot of information in the board that gets lost when you just extract like the layer information, which I think it's like correct to get the geometry when you extract the layer. You want the paths and the traces to be merged together. But then they're not separate. The meaning of the word merge. So if you add the board, then you can have all that information and you can like pull it from there. The other way you could do it is you could kind of like parse the file in a way and pull it from this. And then like what you'd want it to do is to like back propagate into modifying the code. But really the only question is like, how do I, this, if I know I want to modify this translate line, I think we were like, had good foresight maybe without knowing it by confining these transformations to the time of declaration, because it means that when you want to do a manipulation later, you can map it to a very specific line of code. Like it's only going to be moved. Yeah. So the question is just like, how do we draw this line of code? Well, one thing is, whenever we add, we store this information somehow, and then we just need to retrieve it when we draw, which means we need to pass it to this object, which currently it isn't. But if we just add the board as something that like will allow it to have direct manipulations, we still have to go back and find this line number. Alternatively, maybe we just parse the file and we pull it out from the like syntax tree. That could be an okay way to do it. Be kind of magic, but it's okay because it's editor magic. It's not file format magic.
Oh, well, yeah. For sure, there's no way around it. The current SVG doesn't contain all this enough information for this.
But that's the thing that with rendering, like, well, what we can do now is we can add, the layer information, this information to it, but it's not going to have this component information unless that's also like available. And even if we have the board, it doesn't mean you have to like render the shapes through the board, but it could just be used for rendering the manipulation handles.
Mm-hmm. Yeah, then you could just drag the wires in the interface.
And so I think what we'd have to add to board, I don't think we store it at the moment. Like when we add a wire, we just change these layers. But what we could do is like every time you add a wire or a board, it adds like data for the manipulation.
What would be ideal is if you detect whether these points have constants, additive constants, or they are just references to variables, because in that case they are kind of constraints. When you draw in a CAD software, you add constraints between elements. Well, if you have a point that's only variables, it is constrained, isn't it? But
Yeah.
if you have additive constants or even multiplicative constants, we never did that, but we could, then those could be driven by the user in the interface.
Pete had another question.
Yeah.
Can you directly import the output file from KiCad to have full end-to-end toolchain? Also a good question. Do you want to field that one?
So what do you mean by importing the output file from KiCad? Do you mean once you have designed your entire board and you get a Gerber file?
Yeah, I guess that, do you want to import it? You want to import the output file from KiCad. So from KiCad, I guess if you already have it in KiCad, you might not, the file that you use from the schematic. Yeah, so that's an interesting question of like,
yeah,
do your schematic
about it. Yeah.
In KiCad, can you do your layout in here? Is that kind of what you're asking?
Mm-hmm. So we thought about the schematic. In our current system, there is just no schematic. It's the code. In the code, you can see what's connected. So there's a whole discussion of whether we could generate this code from a schematic or the other way around. In our opinion, the schematic can definitely be generated from the code, but not the other way around, because you don't have any geometry information, obviously. So the schematic it doesn't exist, and for now you have to draw it yourself. But yeah, at the same time, schematic is just an idea, so you could even draw it with a pencil, couldn't you?
I think probably what would be most useful, like you always have to draw it yourself. So in a way, it's kind of like an alternative to using a normal. You don't really need anything from a normal like circuit board design tool. But something that you probably often would like is the schematic. And it's an interesting question of, yeah, can you generate the schematic from the code?
From these codes only, I believe, yes, I believe it's possible. It would be awesome to have a viewer for the schematic and the board simultaneously, because this doesn't exist.
I think it's
in all software, it's separate.
It depends on your like heuristics for it. So there are like simple things you could do where it's like, so in this case, everything that's connected, like it has an endpoint on one of those pads. So that would be an easy heuristic to use, but it's not necessarily the case. Because like if you, for example, if I do this, I have a blob board, like what is my schematic,
But yeah, what about T connections? If you have a wire and a T, then
yeah. But this is actually one of the nice things about getting like real geometry from the end, is that you can check like areas. So you could look at the points of all the pads and say, hey, does this fall? Yeah, does this fall within the area? Oh yeah, you could totally do it that way. And you can see.
Yes. Yeah.
Yeah, that would be a nice, that's because that actually just gives you like the ground truth. Like this is the schematic, based on the geometry you gave me, this is the schematic that
the practical schematic. Yeah.
Yeah, because you know that any point that falls within the like bounding region of the trace wire is connected.
Yeah,
so
like
it's very, very easy. Yeah.
And this is novel. It's not a thing currently. What happens now is when you're designing, when you go from the schematic to the boards, it doesn't even allow you to draw wires that way if they intersect. I think it's more fun to go the other way around. You intersect whatever you want and you end up with a failed schematic.
Yeah, so you can make a board and then it tells you what you made.
Yeah. No, but this is really good. We should work on that. I guess a few extra instructions could tell could explain how to lay out the schematic, because otherwise it's going to be a bunch of RASnets. It would be nice to have labels. I often do that in my schematics when I have okay, look, this is motor controller and this is the motor. I guess those 4 motor pins would be on one side of the schematic, and they would not have wires, they would have labels. You see? And those labels are just invisible wires. So if the user could at least tell the API which wires should not be displayed in the schematic, then yeah, I think a really nice schematic could be generated like that. And again, you could drag the schematic around. It could be interactive at some point. Yeah. Yeah, if we had a team of 5 people, it could be done in a week, huh?
Well, I think we have 5 people here, right?
All right, we're running overtime.
Yeah. If anyone
I
has,
think I'll at least stop recording, but we can go on a little bit.